Oh no, there are blue sheets. There are real blue sheets. But yeah, but so this is media. So they want you to tonight join them. Paying for trading? Oh, we are. There's the new one. And there's your slides. And it's really cool. I couldn't steal it. All right.
You're the new guy. I'm not the new guy.
Oh, it's 9:01. How about that? There should be a chair slide too. Okay, so step over, shouldn't I? Okay. Morning, Spencer. Hey. What? Get in?
Hi, it's good. It's good to see you in person.
Yeah.
It's kind of turning into the no one has ever seen Bill and Brian in the same place. But one of them is always there.
I'm a very good Brian. What are you talking about? I'm a very good Brian.
Karen has been really tough.
You know?
Yeah, my daughter actually, one of my daughters actually called me last night and said, Dad, you have to pick me up. No. Really? So I'm not getting white. Come on, wake up. I'll try this one. Okay. Ooh, what? Let's see
You're doing excellent man alone. Just you wait.
Oh, so that means, okay.
If I did, I'll just hang down. I hope Billy can't make this traffic. He's my magic traffic. It's never questions.
Oh, there it is. Up. Oh, yeah, I guess I don't have. Slide this up. Okay, it should show up. Whoa, that's impressive. Someone's awake this morning. So, good morning. I'm Bill Cerveny, and assisting me this morning is Sarah Banks. Brian is in Zurich and not Zurich B. So let me look at the chair slides. So first thing I want to note, so first thing, I need someone to monitor Jabber or MeetEcho. Any volunteers? Actually, I could probably look at it from here. I need someone to take notes. I need volunteers to take notes, please. Or a volunteer. Excuse me? Who should I pick? I pick Alice. Okay. I need a volunteer to take notes, please.
There's a beer involved. I bought a beer, but the chair actually never was.
Okay.
I brought a beer. We brought a beer.
So we have an offer of a beer on the table for someone to take minutes. We're going to go to the 6-pack shortly. No. Yeah, I think. Yeah. No, we need. I think I've agreed to take. No, I'm just kidding. Would you be willing to take notes? Okay.
Susan, you look very happy today. Happy enough to take notes? Happy enough to take notes for us today? Absolutely. I'll take notes for you while you're presenting. Thank you.
Okay. Thanks, sir. Thank you. So we have them to take notes. So let's. So there's a note well thing, and it has a whole bunch of really important legalese stuff associated with the IETF. Next slide, please. We've got 3 documents in somewhere in the IESG space. Actually, there's a telechat scheduled for the PDM option. We've made a lot of progress there. I think we're kind of stuck in the security space a little bit. So TWAMP is moving along, and model-based metrics is moving along, if I understand correctly. Yeah. Matt's shaking his head. So yes, it is. Excellent. So next slide, please. So I guess let's look at the agenda. And so as usual, we start with the working group drafts, and then we move on to the independent drafts, and then drafts which haven't had any active discussion between this IETF and the last IETF become part of the lightning talks. One thing to note is that we're going to have more extended discussion about draft Brockers in-band OAM, which is being introduced into the working group. We're going to start with the alt-mark discussion. Okay.
Good morning. This is the update of the alternate marking technology for passive performance. Can you hear me? Okay. So, this is the update of the alternate marking technology about on passive performance monitoring, and we are at 0.4 version. Next slide. Okay. Now we can look into the document change after Seoul meeting. So we moved from 0.2 version to 0.3 and 0.4 version. And the important modification that have been implemented are in particular a reorganization of the delay section, because there was some discussion during the Seoul meeting on delay aspect of this methodology. So we make a organization in terms of structure of the delay section and also in terms of the contents. In particular, before Seoul, we had three, also the counter. We give three alternatives for the delay calculation, and now there are just two alternatives, single marking and double marking. And the mean delay, that was the third alternative, is just an optional feature that can be used. And I think this addresses also the comments received and all the discussion that was made in Seoul. Then a new paragraph has been added about the delay and delay variation consideration, in particular about how many parameters can be considered, and then for a detailed statistical view of the delay parameters. So many thanks to Al Morton for the help on this point. So next slide. This slide will give you just a recap about the delay classification aspect. So you may recall the single marking and double marking method. In single marking, the first and last packet of a batch is the time reference for the delay calculation, but this does not work in case of auto order, because the first or last packet can be reordered by our network. So we can use the mean delay, that is a simple metric that can be done for the entire duration of a batch. And in this case, we have no impact in case of reordering. Double marking method is, of course, the best choice. So we have a first marking to create the batches for packet loss measurement. And within these first marking batches, we can select some special packets for with a double marked packet. So we can select some special packet for the delay calculation. In this way, we can implement a detailed delay calculation on this double marked packet, because these packets are fully identified along our network. And this is the most complete choice for a statistical point of view and a statistical analysis of our values, of delay values. The mean delay can also be calculated and can be calculated both on single marking packets, but also on double marked packets. And the comparison of these two mean delay can give useful information regarding how the double marking packets are delay represented. Okay, this is just a recap. Next slide. So these are the considerations that have been added. So now the mean delay is just an optional feature because it's not sufficient to characterize the sample, and we need more statistics and extend data. In particular, the double marking solves this issue because a subset of batch packets can be selected for extensive delay calculation, and in particular, the methodology to have this the extensive delay calculation is out of scope of this document, but we make some consideration based on the discussion we had in Seoul. In particular, we can calculate for this double marked packet the median, the mean, the variance values, the maximum and minimum. But the range maximum minimum should be avoided because of outliers. So the stability of maximum delay is not guaranteed. And we reference to RFC 5481 that highlights how the 99th percentile of the delay and delay variation could be more useful for delay representation and delay calculation. Next. So now, after this recap and the description of all the changes that were made regarding the delay section, we make an update about the marking method use case. You may recall the MPLS RFC 6374 implementation, thanks to the use of the synonymous pro label, in order to implement the alternate marking methodology for the passive performance measurement in an MPLS network. Then we have the overlay OM use cases, and the work is in progress in MVO3, SFC, and also in BIR, where we have an adopted document. A new proposal that will be presented probably at next IETF in a Spring Working Group that is related to flow-aware IPv6 segment routing. And one of the use cases that we are thinking about is the application of the marking methodology. And also within IPPM, we have a lot of ongoing work. One is the multiplexed alternate marking that will be presented after. And the other one is the extension of the active protocol for the implementation of this methodology. Next. Okay, now this overview of the RFC 6374 SFL is particularly useful in my view to give you just a sign of how is flexible this methodology. Because regarding the traditional RFC 6374, you use the OM packets to split our flow into batches, but this does not work in case of auto order because the OM packet could be reordered. So by introducing the SFL, we can avoid this issue, we can overcome this issue by using marking. And this is very useful in the RFC 6374 packet loss measurement, passive packet loss measurement. In case of packet delay measurement, the RFC 6374 use the OM packets to measure the delay. In particular, is the delay that is experienced by the OM packets. In general, so it's not essential to use the SFL marking also for the delay measurement. But it's important to underline that in general, the OM packets may not need to be carried on SFL if the delay, because the delay of a particular LSP is a function of the TC bits. But in case we use a label scheduling, so we refer to RFC 5217, the SFL would be required because it's the only way to ensure that RFC and that the RFC 6374 packet experiences a representative delay. So this show you how flexible is this methodology because you can use both on passive and on active measurement. Depends on the context. So next slide. So we think the authors think that this version is a consolidate at a consolidate point. The content could be considered stable, so the scope of the document is well defined, and also it's important to underline that there are some use cases that need to move forward, and this is a foundation document for all these use cases. So we hope that we suggest to move forward with the last code phase. Thank you.
Are there any questions? Not hearing any questions, I guess we're going to start with a working group last call shortly.
Okay, great.
Thank you. Next up in the agenda is discussion regarding the registries, both the initial and metric registry. And to do that would be Al Martin.
Morning.
Morning, Al.
So I'm Al Morton, and for many years, we've been working on trying to specify a registry for performance metrics. Next slide. And if you've been following Facebook, you know that what this is all about. You take the first sentence of your favorite book, like Christopher Robin and Pooh wondered what Piglet was doing. And then the murders began. So I couldn't resist the chance to do that here. Next slide, please. So we have a registry. We have a problem we're trying to solve with it. How can we specify metrics with necessary precision so that they can easily be compared between different implementations, between different systems making the same measurements and so forth? In the original specifications, which was a good thing, there was a lot of flexibility allowed in terms of what streams you use and how dense those streams are. All sorts of things were variables. So we decided you really needed to nail these things down. So we're going to provide a unique ID once we nail some of these things down. Next slide. And so now we're up to version 11. And so it simply described each thing in the registry as a row, each metric in the registry is a row. And there's going to be a series of columns, which you'll see on the next slide, 16-bit flat identifier, blah, blah, blah. Next slide, please. So this is the graphical implementation of what we've got here. We've got different categories: a summary, metric definition, methods of measurement, the output form, administrative info and comments. The orange fields were added recently by IANA. I didn't take the orange color away. And in each of these categories, you can see different columns of information that we're going to nail down about these metrics, so that they're very exactly specified, much more than we did in the original RFCs. And so I think that's a good thing. So now we're off to slide 6. Here's what we're updating in the draft most recently. We've got a continued examination of the new metrics that we've been adding in the next draft. It reaps name element clarifications. In Buenos Aires a year ago, we finally came up with a really good naming scheme. We're still tweaking that a little bit, but we do understand it better. And also, IANA has been working with me, and you've seen some of the mail on the mailing list. IANA has been providing an early review of this draft because it's a really complicated job for them. But the reality is we found a way to make it easy for IANA to implement this and for us to administrate it in the future. So I think that's actually a success right by itself. So we've nailed down what the URI will be. We've changed this a few times, but it's going to be a new namespace under IETF. That's pretty high level, but this seems to be the way that it should go best. So metrics and perf, for performance. This allows other people under metrics to do something and to have another sub namespace here in the future. And then we'll have a URL that always points to a complete textual version of the information that's in the registered metric. And you'll see, if you look at the draft, particularly the initial contents draft, which I'll talk about next, you'll see why that's necessary. Because if this was a usual table on the IANA website, it would be a bloody mess. You wouldn't be able to understand a single thing that was up there. It would be completely unusable. So now we've shrunk that IANA table down to just 6 important categories, and all the detailed information about how to build these metrics is going to be in text files. So on the name element sets, we're going to have a sub-registry on that. And so each of the names will have different things that you can choose from these different categories here. So metric type, RT delay, things like that. You'll see some examples of that in a minute. The method and so forth. Next slide. So we're up to slide 7 here for those playing on audio alone. So the third item we've been working out with IANA is to be sure we nail down the instructions about new entries and to be very explicit about where we recognize possible extensions of the registry format in the future. And that is, you could potentially add a column or maybe even a category to cover things in metrics that we didn't anticipate at this point in history. And so each entry in the current metric that we're proposing, or registry that we're proposing, is going to be mocked up in HML, so we'll all get a chance to look at this and just see how useful it is. That was one of the things I was working on with IANA as well. Next slide. Okay. So one question we keep asking, do the name element sets cover passive measurement well enough? Who's doing passive measurement here? And I mean pure passive. Okay. Well, yeah. So the point is there's not that many out here, but you should really look at the naming and see if there aren't some things that we couldn't add to try to make this a little better up front. So that's a homework assignment for passive. I would extend this to hybrid, any of the hybrid types, 1, 2, or spatial composition. Take a look. Now's the best time to add elements to the naming that will help. Next slide. So now the initial performance metric registry entries. So here's what we're going to populate the registry with once we get down to actually agreeing on everything else. And you can see this draft has a long history. So that's, this is the kind of iterations we've been going through. But we're getting close to the end here, I hope. Next slide. Lots of feedback on the registry contents. We're seeking feedback on the current proposals that are all in this draft. What else the working group wants, and the sort of the regulator guests who join us from time to time. Kind of thinking that actually, the regulators are ones who have sort of the most skin in this game of nailing things down, and the rest of us have to understand what we need to present and develop. So that's the point. All of the sections with proposed registry entries have been updated. So new data formats, new naming conventions. A key metric here, which is an important one in a lot of regulator world work, is this DNS response time. Think about it. This is kind of the predicate for, or the precursor for any website access your broad users can access. And if DNS isn't working, like for example a few months ago when it was under attack, you suddenly find out how important DNS is. So we've got a metric in the draft that covers this. It hasn't had a lot of DNS knowledgeable eyes on it yet, and I'm really requesting that review. And really from anybody from the point of view of, like for example, BEREC in Europe, they've got a DNS metric that they're hoping to measure. So this is something I'm asking the BEREC folks who may be listening, and also operators in Europe who may have to build this metric to look at. So we're continuing to work with IANA to clarify the multi-metric per section proposals. And what that means is we're saving a lot of time by organizing the document so that a delay metric with its different outputs, those will produce a different row in the registry, but it's only one big section in the draft. And that's because all the sections, with the exception of the name and the output, would be identical. So we're trying to save a little work in doing that, and now IANA and I are on the same page with respect to how to do that. Next slide. Okay, discussion and comments. We still want to add more about loss. The model-based metric initial registry entry has a loss metric in it, but I'm thinking that we need to add this to almost every one of the ones that we've got here. In other words, and it should be fairly simple. But we'll look at that. I'll slow down so Matt can get to the mic.
So one of the things that I'm chronically reminding people is you don't actually get a measure of, for most protocols that are your instrumenting functioning protocols, you don't actually get a measure of loss. You get a measure of how often the transport needed to retransmit. And you get a precise measure of the number of retransmits. And there's some heuristic that you don't have any control over that decided whether or not somebody else decided if it was a loss.
Bingo.
So I do not use the word loss. I use retransmits for protocol instrumentation.
But in MBM, we use the word loss because that's a real loss measurement.
This is true. And there isn't an explicit statement in there how long you determined it wasn't reordered.
So that's, yeah. Good co-author interaction. Actually, I've got some slides on the one we've been working on too, Matt. So let's cover that again there. All right, traceroute. There's a small group of us working on that. We haven't made a lot of progress, but that's still something we got to do. ICMP echo request reply. People still want that. I think that's pretty doable. I think that's the last slide on this. Is it? Nope. Next steps. Discuss and close any open issues. I've got something I got to do with Sam Knows, which I got some feedback from Phil about, and I got to check that out. We'll change that if it's necessary. The first two metrics were plus on, I think. Oh, okay. Well, anyway, maybe they'll come back. So I think that's it on this one. How are we doing on time?
You're okay.
How much more?
Well, actually, it didn't start until a little bit late, but you have 10 minutes and we'll still be on schedule.
I'll try to finish it up in 5. Next slide. So here we're off to the model-based metrics, part 2 of the initial performance metrics registry entry. Next slide. Matt and I are co-authoring this, and I've kept it separate because it's Matt and Al working on Matt and Al's draft to try to make it into a registry entry. And really, Brian asked about this last summer in Berlin, I think we were. And then Spencer, after reviewing the model-based metric draft, asked how this would fit, model-based metrics, how this metric would fit into the registry. So it's been a really good and informative exercise to try to make this work. So we've got a nice name there. One way, MBM, active. this is an example of the name. So IP, TCP, sustained burst, those are all metric submodes. And they can come in any order, and they're separated by hyphens there. And then all the major fields are separated by the underscores. The RFC is the one that would actually be the final number that specifies this registry entry. And then the output type is enumerated. And we also have a pass-fail inconclusive output. So those were brand new. We didn't have anything like that in the registry set until we did this exercise. Really important to do. So the sustained burst is not that complicated a thing, but it's described in the draft model-based metrics. And the test in general describes the stream conditions needed to evaluate the target rate that you're trying to achieve on this particular path, the target RTT that you think you're supposed to be using, and the MTU, of course. This is all important. And if you are familiar with Matt's first order equation on TCP performance, those are the things that are sort of there. So you can see where this is coming from. Loss and round trip time are the primary measurements. We've got loss in the larger world now. That's good now that we've done this. We're adding the remaining dated formats, clarified the packet stream generation parameters, and just going on with that topic, but you can switch to the next slide. We have learned a few things about the specification of the parameters in an MBM just by doing this. We have very strict data formats, and so the point is, what are we exactly specifying in each case? And that's helped us to clarify a few of those. So the short answer is the registry format can do an MBM, a model-based metrics draft metric, but we've got a lot of runtime parameters, and they're listed there. So, but that's not a horrible thing. It just means we're allowing some flexibility and yet having a registry entry, and it ends up being a way that you can organize the information that you've had to tweak in order to get the metric to measure what you need to measure. I mentioned the primary output before, pass-fail inconclusive, and so we've also got the options to report the output loss ratio and the mean round trip time in the results. And as I said, we've learned more about this by doing it. So I'll pause there for any questions. I'm sure I've dazzled and befuddled. Yes. Okay. Well, we did get some hands to help out with some of the naming, and that goes for passive and hybrid. So, have we got something at the queue?
Okay. So let's see.
It's my friend Ignacio.
Hi, Al.
Hi.
I have a question because you talk about, for instance, content. Sorry, the DNS response time. I think one of the sections could be in your registry oriented to measure CDN's time response, because it depends on the place or on the network, and this could be very useful for the operators.
I missed the word you said before, response time. It was
Okay.
sounded like
CDN.
something like CDN.
Content network distribution.
Okay. All right, so that would be, let's talk about that some more, Ignacio. I think that might be an application layer response time, but we might be able to look at it at a layer that in transport or something that would be still useful. So let's investigate that a little further. Maybe that starts to sound like TCP setup time, or the three-way handshake, or something like that would be within our purview to specify a metric for.
Yes, but the idea is that some services depends on the place where you connect it into the network. And imagine you put, for instance, DNS response time. It depends on the place
Right.
of the network, and this is another metric that can be taken.
That's an excellent point. In fact, it came up last week in our discussions of this over in Berlin, and so it's a point to note that the propagation delay influences this response time as well. A lot of folks in a lot of countries have their DNS server arrangements so that they're actually not in the same country. They could even be in a different continent, and there you would expect to get a much longer response time just because of the propagation delay. So thanks for that question. Good point. Anything else in the room?
So Brian had a question that he's going to follow up on the list with. The basic question is how to separate TCP metrics where RTX is a lost proxy versus other transports such as QUIC where they aren't.
How to separate, just read that last part again.
Okay, so how to separate TCP metrics where RTX is a lost proxy versus other transports such as QUIC where they aren't.
But QUIC's got the same problem. There's no difference. I don't understand the question because it's not true.
And the RTX part of it, I'm not.
Retransmit.
That's okay. So that's just so that's the retransmit thing you mentioned before.
Yeah.
So so how to separate retransmits from?
So I'll rephrase Brian's question one more time, or read it actually. The basic question is how to separate TCP metrics, paren, where RTX is a lost proxy, close paren, versus other transports such as QUIC, where they aren't.
But the QUIC retransmit metric is a lost proxy, and QUIC doesn't actually know whether the packet was lost. I mean, it's got the same problem.
Okay. Okay, we could follow up on the list on this.
Yeah, it'll be an interesting discussion. I wish Brian was in Zurich B instead of Zurich CH.
Yeah.
So close and yet so far. Bill, I think you're up. Oh yeah, if we can find it, we'll be glad to put it back up. I'll just start backing up there, Sarah, and Phil will stop you at the right moment.
Oddly, it was back on about slide 3, maybe.
Oh wow, you should have got up a long time ago.
Forward, sorry. Keep forward. Another one. The one with the picture. That one. The in yellow calibration on the output.
Yes.
What's that about?
Have you read the draft? By the way, Phil is Phil's a co-author.
I had a quick click and I didn't co-author that bit. So.
No, this actually has a lot of implications for you, Phil, and your role as a service provider. Ahmed from Ofcom raised this point last summer in Berlin. He said, "What's going on with calibration here? What about accuracy? What can we tell about these metrics, and what can we do in the context of the metric registry about this topic of calibration? And I said, let's take that on. Let's see what we can do. Basically, IPPM's metrics have talked about a little bit of calibration that you could try to do with like a local loop back, with trying to tell if you've got competing processes and so forth. It's not a complete solution, but it's worth a look at and to tell whether what we've got there is currently valuable for this topic of calibration. It's about really briefly. It's about a short. It's about a tiny measurement that you make under contrived circumstances to try to calibrate the situation that you're actually making the measurements in at the moment. So, like if you've got some other applications competing for the interface, that could potentially be discovered through this calibration check. Yeah, and let's talk this week while you're here, and we'll sort that out. Thank you.
Okay, so the next draft is T-WAMP Yang.
Good, I'm done.
Mukesh? Yep.
No, I'm not going to leave it. I'm going to.
Al walks away with the microphone.
I could have as well got him to present this one. He's a co-author on this. Why did you have to give up the mic? All right. So this is an update to the Yang model. Next slide, please. The logical model, as we had presented in the draft, is essentially the control and the test system setup, each being managed by and configured by the control by the netcon client. Next slide. So here we have the configuration client showing, actually managing both the control client and the session sender as a single entity, which is one of the options. Same thing with server and the session reflected as a single entity being managed, configured by netcon for RESTCON. Next slide. So the updates, and there were 2 updates since IETF 96 on this draft. We have had an extensive Yang doctors review on the document, which resulted in quite a few changes, especially around trying to make the Yang model a little more descriptive and adding more consistency and references in the draft itself. There was also a workgroup volunteer review, which we took into account. So combine that with the updates that we provided in the model itself, and the work on the better alignment of the packet distribution with the other IPPM work. We believe, next slide, that this draft is actually ready for last call.
Greg Ziti. I sent some comments a while ago, and I didn't get a response. One thing is that use of T-WAMP control is not mandatory. So the T-WAMP test must be able to be instantiated without T-WAMP control. So the current model ties 2 very closely together. Another observation is that this current model has parts that are more belong to or might come from LMAP model, which describes what we can refer, actually recently we have a discussion and a list as a continuous mode. So basically you have a role of controller, programming measurement agent to do repeated tests at certain interval, at certain duration. So that more belongs to LMAP with the controller measurement agent interaction.
Okay. So actually, if I can ask Al for his help. Did you? Okay.
Okay, so Al said to take the discussion offline.
All right. Any other questions?
Offline, you mean on the list?
Right, please.
Okay, because if interested, I can resend my original comments that I sent before Seoul.
All right. So I think that we will discuss with Greg offline during this week itself.
Okay, so is any discussion going to be on the list per se? Okay.
All right. I guess I've saved you guys 10 minutes.
Okay, great. Thank you. Okay, so and then we look at doing what I call at one point. So next we have someone you've heard from before this morning, Mr. Al Martin, with a discussion of 2330 IPv6. Uh-oh.
Oh no, this isn't me.
No, it's not.
So, in situ, performance measurements. Do you want to go with this?
Yeah.
It's not this one.
Brian, we need slides for 2330 Yang or 2330 IPv6.
So, I recommend that you go to Frank.
Yeah, he's coming online. Okay, go ahead.
Hey, are those not in there?
No.
Okay. Wait 5 minutes. I have the slides. But I thought I'd uploaded them. But yeah, wait 5 minutes. I'm on it.
So let's have the next guy come and use the time.
Okay. Okay. Which the timing is good. So let's move on to.
So Frank, you're up.
Yep.
Yes. Okay. Oh. Where do I do that? Yeah, we just switched to you. Yes, no trouble. No trouble.
Sorry for the hassle. I think I need to go and be in that pink spot here. Okay. Yeah. Hey, welcome. So I'm supposed to give you a brief update or intro into in situ OEM. Where's Tal? Come here, please join me. Because we're going to go co-present, and we have Shweta hiding in the back, and she's going to go and briefly, hopefully, say a few words of what's happening at Bits and Bytes later on today. Or no, this week. So in situ OEM, can you go and flip through the next slide? So we've been discussing this in a variety of working groups, but not in IPPM live. We've been discussing this on the mailing list. So what are we trying to go and solve? There's a couple of use cases when it comes to service assurance where we do have a problem today. And I think you can pinpoint that problem to whenever you go to something like speedtest.net and you're measuring that you have a brilliant uplink speed for your broadband connection. Still, everything sucks. Why? Certain providers somewhere on the planet prioritize probe traffic that make you believe your connectivity is great, but your actual connectivity for your application is not so great. And we've seen that happening also, especially in overlay VPN scenarios where providers, despite the fact that people use probe traffic, to go and ensure that a certain quality is there, they prioritize the probe traffic as opposed to prioritizing the customer traffic. So what you want to go do is you want to measure the customer traffic or the quality of experience that the customer traffic has. Same thing goes, there is a variety of scenarios that we've been trying to, for ages to go and figure out. If you use ping and traceroute follows a certain path and is handled by the equipment in a certain way. Quite often, it's not handled the same way as the customer traffic or the live customer user traffic, or whatever you want to call that. And even more so, there is scenarios, and there is this use case that we're going to go and show at Bits and Bytes, where you want to go and select services in the network, and these services are microservices that might be video caches or the likes, and you want to go and choose the best service from a customer experience perspective for that particular application. And again, it comes down to understanding metrics for the connectivity of a particular application as opposed to probing things, because the probe might be handled differently. So we've been distilling a bunch of requirements out of these high-level use cases, and well, I think what it comes down to is we want to add certain metadata that allows us for a deeper understanding of what the traffic does in the network to the live customer traffic. I think that's the core of the idea, and the idea is not really brand new because, well, there's been route recording in v4. The idea has been brought up for IPv6 a while back, but it's never ever really been tackled comprehensively, and I think that's what we're trying right now. So we're adding things to the packet. We call that data fields, and we want to go define them in a generic way so that we can understand which path a particular packet takes, node IDs, ingress interfaces, egress interfaces, when it visited a particular node, so timestamps on ingress, egress, delay through the system so that we understand where certain kind of glitches are. We can or should be able to sequence number packets in case the protocol isn't able to do that, so that we understand things about losses. Well, all of this, I think we start together and understand. In addition, we also understand that the whole thing won't be deployable on the internet day one, because we change and add additional things into the packet, and you might not want to go do that on the global internet, because, well, it also means that things are certainly more transparent than you want. So we see that that's a domain-specific feature day one. So it's constrained to something that has boundaries. And when we started defining things, initially we thought, like, let's do it for a future protocol like IPv6. Maybe that's not even the future anymore. The more and more we looked into this, we said, well, it's useful for this transport, for that transport, and whatever, but it's useful to define it once from a data fields perspective and not over and over and over again, so that we diverge on how we do things in certain transports. So we want to define the data fields once and then work on the various endcaps in various working groups, and Tal's going to go touch on that in a minute. There is a bunch of things that we need to go consider. Security is definitely top of mind for everybody. So you add additional things into the packet. What happens? Well, given that these things are inspected along the path as the packet traverses the network, we need to go and figure out that we build something that is suitable for both software and hardware implementations. And the way software processing works is not necessarily the same way as hardware processing works. So if in software, adding a big chunk of data to a packet is expensive, and then later on just updating fields into the packet is relatively cheap. Whereas with hardware, if you add a big chunk of data into the packet, it's relatively cheap, but looking up a pointer of where to place the information into the packet is really expensive, which is why, well, IPv6 extension errors are a little hard to do in hardware because of all the pointer lookups. So we need to go do something that is both suitable for hardware and software, which is why we have slightly different data fields for those different implementations. ECMP is definitely, I think, a key thing, and all these other things, and I think Al Morton brought them up on the mailing list when we're discussing things here, is we need to make sure that these packets, given that we want to measure live user traffic, are really handled the same way as the packets without it, because otherwise we haven't really gained anything. And we might want to even test on that. So we want to go come up with procedures here that allow us to understand whether that behavior is really true or not. So key point, it's in the requirements draft, by the way, by now. So thanks, Al. Management and control, so nothing comes without being able to also control this thing and also expose these things. And, well, we should go and work on models that allow us to do that. And finally, well, there might not be only one level of in situ OEM. There might be multiple. So you can run SRv6 over well, an IPv6 transport and have in-band OEM information or in situ OEM information at both levels. So we should go and look into layering concepts very much like we have layering concepts in all other IOM mechanisms. So next slides, please. By the way, we gathered these things in a private draft, the requirements draft, as we refer to it. Well, it's all there for anybody's pleasure. So what it is in a nutshell, I think I was already alluding to it, is we add metadata to packets that are customer traffic, right? We don't really send extra probe traffic. So from a classification perspective, and again, thanks Al for hammering down that path, 1799 would call this hybrid type 1 OEM because we're latching onto the user traffic. So we're sending not extra packets, but we're sending extra data. The whole thing is defined in a transport independent way. It can be processed per hops at certain cases, sometimes only at the edges of the domain, sometimes specific hops only. So if you're only going to go verify that certain packets visited a particular hop, then you will only be looking into these particular hops as opposed to every single hop. And we need to go and put in the information that we discussed in the requirements area earlier on. Well, from a deployment perspective, for sure we need to go do that for V6. For sure we need to go do that for SRv6, NSH, GRE. Those things are defined in another kind of complementary document that we use as a kind of a scratch pad for ideas on how transport encapsulations can look like. That's the transport draft that we have. And we use this as a guidance for the reference implementation or the experimental reference implementation that we're trying in FIDO VPP as open source. Focus on the specific domain. Right now, we export that particular reference implementation that we have, exports things over IPFix, relatively straightforward, and you can publish things or republish things then into, well, Kafka or whatever you like. Key thing, to the earlier point, it needs to be implemented and behave like real customer traffic, despite the fact that we added information to the packet. Next slide, please. So this is where we are. So we have a bit of a history. We introduced the overall story in IETF 96 in Berlin. We revisited the whole thing in 97 in Seoul. And we've been presenting since then to a variety of working groups, including OPS-AWG, SFC. We've been discussing it here on the mailing list. Fun story is that OPS-AWG wanted to adopt it, but then, well, maybe I'll let Mira talk to this topic rather than I. The IESG had a bit of a discussion on where it should go, and the final recommendation was go to IPPM. It's the best fit because it's transport relevant. The IPPM agenda already covers it to quite a bit, so which is why we're here as the most appropriate place for adoption. And we've done a bit of a demo at IETF 97 at Bits and Bytes. We'll have a broader demo on the Comcast table later on this week. From an overall drafts perspective, it's part of a bigger story, but the key thing is the definition of the data, the independent data records. There is an open source reference implementation in FIDO. From a control perspective, we've been focusing on control code in Open Daylight. So that's part of the Carbon release that's coming out. And there is a GitHub site that also points to a bunch of YouTube demo videos and the likes. Next slide. So we've been incorporating a load of feedback based on the discussions we had in the various IETF fora. Originally, we called this thing in-band OEM, which is why the drafts still carry that name. It's changed that name. We can change it once we become a working group draft. We call this in situ because that's more appropriate. So thanks for Eric Nordmark for proposing that name. We properly classify to IOEM now as what is, well, defined in 1799. We've been aligning with other drafts that do similar things, Petter's draft on the data plane probing, and we've been evolving the data fields quite a bit based on requirements that we've been hearing. So key thing was, well, people want sometimes long or short formats, compact or not so compact, for timestamps, node IDs, and whatever. People wanted to go and measure the queue length on particular systems. That's been done. If you look at what the P4 guys are doing or what the Barefoot chipset does today, that's a key capability that helps you even more smartly schedule packets. We've been coming up with options that are either hardware friendly or software friendly. Everything is for byte boundary aligned now. We cleaned up a load of nomenclature that's been a bit of a mess in the early drafts, and we've also started to independently define data fields from how they are transported, because initially the container was a little bit linked to how we transport the container. I think all of these things have been really figured out and made independent. And in order to get that a little bit better understood, I think I'll hand that to Tal to go and talk a little bit further and more detailed on the individual data fields that we've been defining. But you just come along, and I think we can go on surface questions after that, because that is really the heart of what we want to go to achieve here.
Thanks, Frank. My name is Tal Mizrahi. I'm from Marvell. Next slide, please. And we're going to talk about the data format draft. So this draft defines common data fields which are encapsulation independent. And that means that down the road, we expect that probably there are going to be separate drafts for each different transport. So for example, we're going to probably have a draft for IOM over NSH, a different draft for IOM over segment routing, and so on. Currently, in the next few minutes, we're going to focus on the data format draft, which is in-cap independent. Next, please. So when we talk about the data or the information which is transported in IOM, there are actually three types of information. That's what we see on the slide. One type is information which is updated or incorporated on a per node basis. Every node along the path adds that information. That's what we see on the left. Then on the right at the top, we see information which is updated or incorporated on a subset of the nodes along the path. And finally, on the right side in the middle, we see information which is on an edge-to-edge basis. So first of all, if we talk about the per node scope, this includes various types of data. So a packet which incorporates IOM information can have any subset of these fields. For example, there's hop limit, node ID, interfaces like ingress and egress interfaces, timestamp, which represents the time of day. There's also transit delay, which represents how long the packet has spent in the current device. There's the state of the queue, which the packet went through. And there's also a couple of flexible fields. And like Frank said, some of these fields include both a short form and a long form. So that was the per node scope. When we talk about information which is updated by a subset of the nodes along the path, one example for that is security related information, like validating the path of the packet. And we'll talk about that a bit more later on. And edge-to-edge information, one example for that is a sequence number. We'll also talk a bit about that later on. Next, please. Okay, so the information which is updated on a per node basis, this is called trace information. And basically there are two different approaches here, or two different variants of how this can be represented. One approach, we see that on the left side, is a pre-allocated approach. That means the first node in the path pre-allocates all the required space in the header and increases the packet length. And then every node along the path just incorporates its information into the pre-allocated space. So this option or this alternative is more software friendly, like Frank mentioned earlier. And on the right side, we see the incremental approach, which means that every node along the path slightly increases the packet and then incorporates the information into that newly inserted bytes. In either case, there's a header at the top, followed by node data elements. So for each node along the path, in this example, we see n+1 nodes. It's going to have its own nodes data element, which includes the relevant data fields. Okay, so next slide, please. So specifically in the trace header, one of the important fields is the ION trace type. So this is actually a bitmap, which defines a set of bits. Each bit corresponds to a specific type of data. So this bitmap defines which types of data are going to be incorporated in the rest of the data elements. So for example, there's 1 bit for the node ID, 1 bit for the transit delay, and so on. Next, please. Okay, so now we're going to see a couple of examples of what kind of data fields can be supported. So in this slide, we see one data field which includes the hop limit and node ID. It has both a short form and a long form. On the right side, we see a different data element which includes the ingress and egress interface ID, also has a short and a long format. Next, please. Here we see a data field which incorporates the timestamp. So the timestamp is based on the IEEE 1588 time format. And it's actually split into 2 fields, timestamp seconds and timestamp nanoseconds, which gives you the flexibility if you want to incorporate only the nanosecond part, if you think that that's enough. Or you can include, for example, both the seconds and nanoseconds. And that gives you the information about the full time of day. There's also a data field, which is the transit delay. It basically includes how long the packet has spent in the current device. Next, please. Another data field is the queue depth. It basically tells us what's the state of the queue which was used for the current packet. And there's a data field which is kind of flexible, opaque data. The schema ID and the length basically defines how this field should be interpreted. Next, please. So this is an example of what a node data element is going to look like. In this example, we see there are 4 data fields. The first one is the hop limit and node ID. The second one is the interfaces, then timestamp, and then application data. And like we said earlier, the IOM trace type is the bitmap which defines which fields are present in that node data. Next, please. Okay, so far we talked about the information which is added on a per node basis. We said there's also information which is updated or used by a subset of the nodes along the path. So one type of this information which is currently defined is the proof of transit. In general, proof of transit is defined in a different draft, not in the data format draft. Specifically in the data format draft, the data format is defined. So like we see, basically the proof of transit consists of 2 fields. A random field, which is kind of a packet identifier, followed by a cumulative field, which is used for by each node for validating the path. And in general, the purpose of the proof of transit is to be able to validate that the packet went through the correct path, the path we expected it to go through. Next, please. And finally, there's edge-to-edge information which is used only by the edges. And one type of this information which is currently defined is a 64-bit sequence number. And this is going to allow the edges to check whether packets were lost, to check whether there was reordering in the network or duplicate packets. So this is basically the sequence number. Next, please. Okay, so I believe we're done with the description of the data formats.
So there are a couple of demos. Like mentioned in the status slide by Frank, we have the reference implementation of this in FIDO, which is a Linux Foundation project, in a software data plane called Vector Packet Processor. Using that implementation there, we have 2 demos, one with in-band OM data being carried in the application traffic. That's the MNEcast demo, and in-band OM data used for fast fault detection and isolation using a probe traffic, which is the second demo. In the MNEcast demo, we will see the concept of IPv6 content networking with a video stream split into video segments, each segment getting its own v6 address and hosted at multiple locations. And then in-band OM data is used to measure which is the best server at any time, and it's used for server selection. That's That's the MNECast demo. And in the UDP Pinger demo, which is the second one, we create UDP traffic for a range of ports so that we cover multiple ECMP paths in a data center network simulated for the demo. And we insert the in-band OEM data to see if all the ECMP paths are covered. And we also measure the delays in each of these paths. And when there is a failure in the path, once it is detected, we use something called a loopback flag that is there in the data draft. So that is used to isolate the fault and detect the path and isolate it to the link and node that has failed. And that's the second part of the demo. So you can visit us at Bits and Bytes for more details on both of them. Thank you.
Next slide. So summary. As I said, we've done the shopping tour across a number of working groups. We've incorporated a bunch of feedback from all these discussions already in the drafts. We had a lengthy discussion on how to get it adopted. As I said, initially, OPS-AWG was the landing spot, and then ISG believed differently, and we got the suggestion for IPPM, which we're very happy with. We've discussed things on the IPPM mailing list already, and the 03 version already incorporates a bunch of that feedback that we got. And so I do believe we are ready for adoption in IPPM, and well, we can open things up for comments, questions, and whatever.
Hi, Greg Mirsky, ZT. So we'll have to rewind all the way back to the original first slides. Okay, so first I want to point out that it's somewhat of a misunderstanding of fallacy to characterize active OEM as out of band, which is all through this document. One of the good examples where it's not the case, it's an MPLS OEM, because if you're using entropy label and a GAL label, then you can ensure that your active packet will follow exactly the path of their data packet, even in ECMP environment. So if you do your active OEM properly, you can ensure that you're in band. Second of all, changing the length of the packet will affect the transport treatment of the packets if they are doing load balancing. So you cannot ensure that your enlarged data packet will follow the same path as original packet before it was enlarged. So here you cannot really guarantee that, because the transport can balance based on the packet length if you're doing it in applying an overlay layer. Then the second to what Tal was presenting, I would suggest consider support of NTP timestamp as well, because that's another broadly used format. And for example, RFC 6374 packet loss and delay measurement in MPLS network has a provision for that. So what's then? Yes, and if I recall correctly about their adoption by IPPM working group, there was a agreement that first IPPM working group has to be rechartered to accept this work.
Okay, thanks. I think a quick one. I think especially the first comment points back to the comment that Al made earlier on. If we deploy it, we need to make sure that with and without the metadata being added, the packet will behave the same way. And that is why we really constrain things to a particular domain that has these constraints enforced. So I think that's why we make that particular split. The NTP comment, yeah, well, let's see how we can go and slot in that particular format along what we have with 1588. I think more options are always an option. More options are not great because that's more pain from an implementation perspective, but if we feel that we want to go and add them, absolutely.
Actually, what I wanted to point out is that if you limit your applicability to domain that doesn't, transport doesn't do load balancing, then I really question the benefit of this proposal and can point out that the same can be easily done by selecting the appropriate domain and doing appropriate instrumentation for the active OEM.
Dangba from Huawei. So I do have a question for this as well. I have same concern of adding so much bits to the packet, and that will definitely changing the behavior of the packet traversing the network. And then second, you cannot guarantee every node in the network will be able to add all those features, those bits. So I'm questioning the some level of like OEM, like I agree with the requirement, the use cases, they're all good. But the data proposed today, I think is way too large. And compare with other methods like mirroring, like if you suspect any flow is having trouble or being delayed, or there's a complaint about this particular flow, we can use similar method like being able to do mirroring at certain point in the network. Then you can actually monitor the real custom traffic, how they behave in the network. That's just my concern.
Well, I think I'm not arguing that there is different approaches. Well, we found a bunch of customers that find this approach particularly useful. So I'm arguing for the addition of another approach. So we want to go put another tool in the toolbox. I'm not thinking of deprecating any of the existing tools.
Okay, and just a suggestion that if we want to adopt them as a working group, the framework I think is good, but the data model itself I think needs some more alternative proposals to compare.
Which is why I think we want to go to get it adopted so that the working group officially works on it. That's the entire idea.
Not the data model per se. I just want to voice my opinion. I find that is way too large than what is on the table. Thank you.
Yeah, Kulvin as an individual contributor, to point or to take the points up from our previous speakers, I believe the scope here is basically a scenario where you have tunnels, right? Where you anyway add another header or something, and then you can add this information, or is this my misinterpretation? No, I'm asking a question.
So question is?
Is the scope here tunneling where you add a header anyway? Or is it?
I think that's not too straightly defined, but it will go into a bunch of quote-unquote tunnel environments, right? So if you consider a GRE tunnel, if you consider a SRv6 tunnel, we're not longer supposed to call that tunnel now, it's called policy, right? But it's a tunnel. Policy. Or NSH. So all of these things have a provision to eventually carry that style of metadata. And we want to go and slot that in. So whatever you want to go and call transport or tunnel protocol, but I would agree that, yeah, I think what we want to go and genericize is how this OEM information is slotted into the various transports, and many of them are tunnel protocols.
So let me phrase this question differently. So my understanding was that you add this information at a point where you anyway add additional information.
Yeah, correct.
Right.
Correct.
And as such, I didn't think there's like, you will increase the packet anyway.
And we don't have that defined for many of these operational environments.
So I think,
including SRv6. Look at the SRv6 draft right now. The OEM section is empty for a reason.
I'm not sharing a concern about putting additional data, and then you might measure the wrong thing because you anyway changed the packet. And the other question is, do you put this into every packet then?
Well, I think if we want to go and have that here, we will go and use a classifier for what traffic is of interest. Maybe all the traffic is of interest. So we've seen multiple approaches there. Some people say, well, track all the traffic, and then at the very egress, drop all the information that you're not interested in. So by default, tag everything and drop it, or only selectively tag based on, you know exactly, I'm interested in a particular application that runs on port 5000, whatever.
So I asked the question wrongly. Do you put this into every packet of the same flow? Like if you decide, do you decide it on a per flow base? If you decide to track a flow, then you put it into every packet of the flow, right?
Yes, typically
Yeah.
yes.
Okay. That
But
also
again,
makes sense
not
to me.
even that is 100% ensured,
Mm.
because we've been debating concepts on how can you reduce the overall amount of, because you're creating a load of information, you need to go and export that later on. So either you drop it off the floor or you not even consider to add it. So day one, you can look into sampling on ingress to only tag, say, a portion of the traffic, even for a particular flow, in order to reduce how much information you gather in the network. So I think all of these concepts apply.
Mhm. And final comment, so I think there is space for optimization, the data format, but I think this is the right group to get this input here.
So I think we can optimize further. We've also been debating quite a bit. So there is ways to go and embed, say, the node ID information, so that the number of nodes that you visited in a almost length or hop count independent way up to a certain number. So I think we have schemas that allow us to embed things into 64 bits for path lengths up to 32 hops. The downside of that is that you need to go and apply massive math on a per node basis in order to get to that compression. And those concepts we can debate on, right? So we can be more compact at the expense of doing, well, calculations at every single hop. Right now we just drop information in, and that's lightweight, and it's easy to do for an ASIC. If we ask every ASIC to do, well, mathematics that include large factorization of large prime numbers, we can do that as well, but it's, well, no longer that cheap from a computational perspective. But we can be far more compact than we are right now if we want to.
Adrian Farrell. I'm glad this work's found a home. I'm as tired of following it around the IETF as you are taking it around the IETF. So any home is a roof, and we can live under it. I think the questions you've just been getting, especially the last set of questions, indicate that we're not quite sure what scope we're working on. So to take a case in point, the question of, is this OEM data only being added at the same time as you add an encapsulation, is a question I don't believe has been properly thought through and discussed, and affects the whole data encoding question. So I would like to see us put a bit more effort into the document that's this slide, specific slide, projects. In other words, the requirements document. Get our heads completely around that, nail that down as a working group thing, push it forward, and then move on to the data encoding. So that's not saying abandon your work. That's saying pace yourself properly.
I think fair point. I think the main question that you raise is a question on encapsulation as opposed to data fields definition. And I do believe we can progress things in parallel. And if you look at the latest IESG statement, the most recent one, it actually promotes doing things in parallel as opposed to sequencing things like, oh yeah, well, discuss requirements for quite some time and then work on the solution. We do have a solution. We do have a solution that has relatively broad support. So I definitely want to go and progress the solution. We can work on the requirements stuff in parallel. And we can even go and adopt the requirements draft in this working group if you feel like that's useful, right? I'm not anti that at all. If you believe that that should be done, we can obviously consider that as well.
Hi, Frank. So my name is David from Mellanox. I'm actually a co-author of this draft. And I must say that we actually implement most of the things that here, especially all the data feeds in our newest silicons, 6.4 terabit per second. And we work very hard to do it, hardware optimized. And we believe we continue to update it. And the draft is capable to be implemented by real silicon hardware. That's one thing. Second thing, regarding regarding the entropy, Nobody can guarantee today that all the forwarding decision will be done by the entropy level absolutely, because there is a new way of dynamic load balancing that we use the microburst and stuff like that, that not everything is being forward according to entropy labels. So we have to be very careful regarding that as well. With the rest of the comment, I totally agree. Thanks.
Thank you. Greg Mirsky, ZT. So I think I have a question to Tal more. So you mentioned that in encoding you have a bitmap that indicates which fields are present. Does order of these bits indicates the order of the fields in each record as well?
Yes, it does.
Okay, then what happens if you have multiple flags, but some nodes that you traverse do not support certain option, and then they skip it, so how it reflected in a field?
So there's a default value, which means if the node is not capable of supporting a certain data field, it assigns a default value, which indicates to the end node that this field is invalid and the node was not able to incorporate it.
Okay, and what happens if node doesn't support this feature at all?
It needs to support the ability to,
okay, so basically,
to assign the default
okay,
value.
what I'm getting to, no, may I finish? I'm getting to experience that we have with the residence time measurement, that you need to have capability advertisement to know which nodes support what. Otherwise, you are for forklift. So you cannot introduce this feature in a brownfield and have some heterogeneous mix of nodes along your path that support and don't without clear understanding their capability.
I think you agree, Greg. There is a room here for control protocol to synchronize all the nodes in the networks or in the path. So that's why we need a control protocol.
Yes, exactly. So you need to use some protocol, probably IGP, to do capability advertisement, and then you need to advertise capability probably for each and every data that you want to export. And at the same time, you might want to consider it when you are designing your path to hit more nodes that are capable. So very similar. I can point you to the residence time measurement document that now is getting into RFC, and so we have to deal with it to measure residence time to support transparent clock and PTP.
Hi, Mike Ackerman. First, I want to thank you for some really interesting work, potentially with some good real-world results. So thanks for your efforts. My question is implementation layer. You mentioned that extension headers probably are not a good idea. What is a good idea, or how would you do it in the IPv6 transport?
Well, not necessarily, right? So I think the running code that we have right now uses v6 extension headers as a natural home for doing that, because, well, what do you have in plain vanilla IPv6, right? If you have a tunnel end cap, then, well, you can latch onto that tunnel end cap, because in many cases, it's either there and not really defined, or it's not there. So we can add that on. But I think for v6, we likely use extension headers.
And so that leads to the next question, which I'm sure you're well aware
But
of.
it's like not here, right? So I think this is a six-man fight, very likely.
Exactly. That's what I was going to ask. So is this for?
No?
If I can,
Well,
it'll raise its ugly head here too, and everywhere else you go. But
we can do it here.
The unstated question is, so if you're processing exclusively at middle boxes, and I'm assuming this isn't for end hosts, is that true first off? That this would not be implemented in a host?
Well, no, absolutely.
Oh, it could be, okay.
Yeah, sure.
And I'm assuming it's in middle boxes where you're not supposed to process extension headers. Do you have any comments on that particular issue? One near and dear to many of our hearts.
It might well be that the thing is processed by boxes that don't exist in the IETF. Yeah, could happen. So that you do this on a node that doesn't exist, you add it, and you remove it on a node that doesn't exist. You can add it, and that would be nice if you can add it right on the host. or you can edit on a stack that resides within the host. That's what we're doing in the demo that Shweta mentioned earlier on, where we're co-locating a stack that is able to do that with the host stack. So the kernel passes it to the stack, the VPP implementation, and from then on it travels through the network and hits another server where we have a stack that is able to process it, and then it hands it off to the kernel. So that's obviously an option, but kind of tackling the problem that is going on within 2460 bits, don't kind of drag me into that muddy water until it's kind of cleared up there.
I'll drink to that. Again, interesting work.
Because I don't want to go and be, let's not take that debate on here.
Yeah.
But there is useful cases, as you see, where you want to go do that on a middle box that does not exist in the IETF.
Agreed.
Correct.
Thank you for your effort.
Okay, so we have one more comment from the floor.
Carlos Pignataro, Cisco. I just want to comment on Greg Murphy's last comment about the need for a capability advertisement via IGP or whichever other means. I just want to disagree with that stance. If we have the data plane encoding is such that we have a bit field and each bit specifies a particular feature. If that feature is not supported by a node, but a node actually supports the understanding of the bit field, it's gonna essentially say, I don't understand this, but it will actually have the space. If a node, on the other hand, does not support IOEM at all, it's gonna transparently pass it. So the problem that Greg is trying to explain doesn't really exist. There is backward compatibility with nodes that don't support IOEM. There is backward compatibility with nodes which support some but not all of the features that are specified in a bit field. And there is no need for a capability advertisement and for continue to overcomplicate the conversation with IGPs or whichever DHCP. There's no need for that. Since I'm here, I also want to share that grep on the draft, the word inbound, the word passive don't exist, so we can actually also suspend that conversation. Thank you.
So I tend to agree that a capability announcement in an IGP is something that could be considered, but is not really required, given that, Carlos, as you say, if a node will not be able to do it, it will just simply ignore it and not update any of the fields. We will discover that because the hop limit field won't be updated by that particular node. So the end system that's doing the decap will understand that there was a node in the network. But coming back to the domain argument, if you know your network, you know what your network's devices are going to go do or not do. So if you know your domain and you have an understanding of what your network does or what is deployed, it might not be that much of an issue.
Okay. So I want to bring in Brian because he's been waiting a long time. And yeah, Brian.
Hello. Actually, you can go ahead. Let Greg talk. Let Greg talk. I want to take the last word here.
Okay. We have roughly 7 minutes left.
Okay. Greg Mirsky, CT. I believe that what you refer as knowing your domain is knowing capability of your nodes. How you learn it, whether it's SDN-wise or it's else-wise, so it's still northbound interface. Okay, so you still somehow announce your capability, what you do.
Okay.
Another thing is that you're basing your assumption on how some overlay layers process TOVs. It's not necessarily the case for all networks. In some networks, if you don't know what's there, then you just drop it. Okay, so again, it might be applicable to some networks, might not be applicable to other networks.
Spencer Dawkins is the responsible AD for just a second. Two things. One is that I think it's going to be, the conversation you're having about knowing your domain and not knowing your domain. I think it's going to be very helpful for you to have text in there that looks like an applicability statement. And that's number one. number two, I think that having that is going to make it a lot easier to get good security review. And as the responsible AD, I would encourage that if the working group does adopt this, that they start working on security review early. You know, like don't wait for IETF last call.
No, that's a very good point, and both are very good points. So there is a bunch of stuff. So kind of rewinding a little. There is a bunch of stuff, especially with regards to the domain concept, that we right now have in the requirements document. We would need to go and carry that into the data draft if we're just adopting that one as a working group document. If we're adopting the requirements document along with that as a working group document, I think we have it already. But otherwise, we can merge that into the one document and then have that as a single place of information. I think either way is fine, but I agree that verbiage or a bunch of the verbiage that we have in the requirements document right now needs to be in a relevant document, because there's also sections on security, to your point, that right now sit in the requirements document that would be very relevant in the data draft.
Yeah, Kulevin, just want to emphasize this point. So there's a big
Could you do me a favor and shout?
There's a big difference. I want to just emphasize Spencer's point. There's a big difference between applying this to a trusted domain where you know all the nodes belong to you and you have configured them correctly, or applying this to the internet as a whole. And if you don't go for a trusted domain, then you have to improve in security a lot, because then you also have to ensure that this data cannot be manipulated by other boxes in a way that you don't want it, and so on. So it's a lot more effort. I don't see this right now with your proposal. I see this can only be applied to a trusted domain.
Correct. Okay, Brian, you're back.
Hi.
So can we ask the adoption question?
Sorry. Let me, I've got a bunch of feedback here.
There you
I'm
are.
turned way up. And I'm about 300 milliseconds late. Okay, good. Yeah, we can ask the adoption question in a second. I wanted to make a couple of comments as an individual first. I think I want to reiterate Spencer's point that we need to be very careful about applicability and scope, about what kind of networks we're talking about here and what kind of networks we're not. Because the capability, I don't even want to say capability advertisement or capability negotiation, because those are mechanisms. The capability agreement system by which you're actually going to make sure that all of this stuff along the path actually has the right level of understanding here in certain areas of applicability is a very important thing to consider. One thing one of the ways that we could do this even is we could essentially say, we're going to limit this in the first iteration to tunnel endpoint to tunnel endpoint encapsulations. That makes a lot of your efficiency arguments or efficiency problems kind of go away, because you're adding an encapsulation anyway. And really, if it's the tunnel endpoints who are communicating with each other and then to things along the path in the outer encapsulation, that makes some of the more problematic security problems no longer problems, and it probably solves most of what you need to do from a measurement and management standpoint. From that, I want to put my chair hat on, which is actually up here behind me, but yeah, it won't fit on my head with the headphones. Greg raised the question about the charter, and we have discussed what would have to happen to the charter in order for this to be adopted. To me, it looks to me very much like this work is covered under paragraph 4 of the charter. Additional methods will be defined for composition and calibration of IEPPM defined metrics, as well as active, passive, and hybrid measurement methods for those metrics. This looks very much to me like in the terminology that we came up with and everything in between of 70, whatever, 99, that this is very clearly a hybrid measurement method, right? Because your endpoints are putting additional information on the path that's meant solely for measurement by the middle points. There is, however, the explicit cutout in sentence 2 of paragraph 1, specifying network or lower layer OEM mechanisms out of scope for the IPPM charter. To some extent, I wonder how much that particular cutout is a problem, in that while this is called in-band OEM, I'm wondering how much of that is a terminological accident of where this work started. This doesn't look a lot like traditional OEM protocols, right? I think that one way that we could sort of fix this, though, in the IPPM charter would be to add basically a single sentence, a cut in, that said in-band methods for the measurement of IPPM metrics and in-band measurement methodologies for the measurement of IPPM metrics are explicitly in scope. We probably need to do the wordsmithing of that on the list, but I wanted to get a little bit of sort of the room's feeling about how a small tweak to our charter would work for bringing this stuff in.
So we also had a, oh, okay, Adrian dropped off, okay.
Yeah, to Brian's comments, Greg Mirsky, ZT, again, I would try us not to use in-band, out-of-band terminology, because this is not characteristic of any specific OEM method, whether it be hybrid or active. None of it inherently in-band, out-of-band.
We can call it in situ, right? So no worries.
Yeah,
We fixed the nomenclature.
if that makes, you know, like anything that we want to call it, we can call hybrid type 1.
So we are now running closing time. Nalini, really quickly?
Yeah, real quick. Yeah, I'm Nalini Elkins. If we need to do the charter, I think maybe we do the charter. I think clearly this kind of work has to do with performance metrics. A lot of thought and really good work has been put into it, and I can really see that something like having PDM at the endpoints and using this in case there's a problem, something like that. I can see that would be a tremendously useful kind of thing. So if we need to redo the charter, well then maybe that's what we need to do.
Spencer?
Mr. Spencer is responsible AD again. I would just mention that usually charter updates are more or less complicated, but with this one, if any AD discusses it, I tell them it goes to their area.
Okay, so quickly, can I get a feel for who is in favor of adopting the draft with hums? Opposed? I think I heard a majority in favor. Okay, great, thank you.
Thank you so much.
Great.
See us at Bits and Bytes, even if we just want to go and have some food.
So Al is back on the agenda, or we are set up with slides?
So Karidi says that I haven't done enough presentations today, and he really wants to hear one more from me. So we've decided to update the, oh, look at all the people leaving.
You're popular, Al.
Well, this is the real IPPM stuff we're going to talk about now. I mean, dating back all the way to our original framework, where we specified all the important details of how to make active measurements on networks. And in the process of updating that, we learned a few things, and that's what this draft is trying to solve. So I'm a co-author with Joachim Fabini, Nalini Elkins, Mike Ackerman, and Vinayak Hegde. And this is our draft. It's the second version. And next slide. Okay. So I mentioned the framework, RFC 2330. It describes these prerequisites for measurements, valid measurements. Your packets have to be standard formed. No one knows what that is if you haven't read this draft. But we defined it there. Actually, I shouldn't say we. I should say the founders of IPPM defined it there. And they did it in the context of mostly IPv4. We think IPv6 is coming. There's some guys working on it. It was a long time ago. So now, IPv6 is among us in a big way. Also, they recognize that the result of the measurement may be affected by the packet type. And we had a very detailed description of what constitutes packets of particular types. And you have to specify that when you're generating these packets in order to make measurements with them. So that was the concept that our founders called type P. Packets of type P. And you specify lots of things about them. And by the way, IPv6 packets have a lot of options. Destination option headers and extension headers and hop-by-hop headers and so on and so forth. So we quickly recognized, next slide, in the context of bringing our loss and delay metric standards up to the full IETF standard level. In other words, we've been living with this for a while. We wrote the specification years ago. It's widely implemented, and there's a few things we need to change to update it or whatever, but the main point is now we can call this what's called, a full internet standard. We did that with 2 metrics. It was very interesting to get that to happen. We actually had comparisons among 2 different implementations showing that the specifications were of sufficient quality that equivalent measurements could be made using the original specifications. And that was something we had to agree on here in IPPM, because it's not about protocol compatibility. That's the usual test of moving to a full internet standard. We're talking about results equivalency. And that's what we nailed down in an RFC that I'll be glad to give you later. So we have a special version of this for IPPM. So when we reviewed these 2 drafts, moving them up through the IESG, Brian Carpenter raised the flag, and Brian Carpenter was the absolute right guy to do this. No IPv6 coverage. So we're now changing our framework. The right way to handle this was not to change the 2 drafts that we're moving through on delay and loss, but to go back and change the fundamental framework, the RFC that provides the basis for all of our measurements. And that way we can make use of this information in every metric we define. So that's what we've done. That's this is the dedicated draft that updates the framework. Next slide. Okay, so we got adopted as a working group item, and then late last summer we had some excellent comments from Fred Baker and Marius Jugescu. And so now we're updating these 2 sections. We've covered the topic of extension headers much more completely in the type P definition for standard form packets. And that's actually a topic of a little bit of controversy in the V6 areas. I think some people want to see all of the extra headers unsupported or go away or something like that. But that's something that we're tracking closely. We've added text about a load balancer as an example of Class C. Class C is a concept that was described in the original framework. It's what Frank was just referring to, that if all the packets defined within a given class, Class C is what we're calling it, just nomenclature-wise, just the same thing as type P. It's a class, and all of these packets are being treated the same by the network. It's a really powerful concept, and something our founders came up with and nobody did anything with until just now. So now we're doing more with the examples here, and it's become a very important concept in the discussion of in situ ATM, OAM, not ATM. So we've got plenty of examples where the type of packet changes from on its transfer path from source to destination. And we need to talk about those because in a lot of cases, they may change the measurement results. And that's our main concern, of course, with all of this. And we're, again, IPv6 is among us, but it's not a flag day kind of transition. So we're going to have to live with a long time of IP address coexistence from the two different families. And what that means is that there will be V6 to V4 and V4 to V6 transition technologies involved. And so now we've got a major new section that covers network address translators, the transition stuff for 4 to 6, 6 to 4, and also header compression that can appear in that context. Next slide. Okay, so further discussion is needed on these three topics. And I'd like to see this either today or on the mailing list. Handling of large packets, including in IPv6, which includes fragmentation of, because of extension headers, path MTU discovery, PLMTUD, which is the non-ICMP aided version of PMTUD. The extent of coverage for 6 low and V6 header compression, and the continued need to define a minimal size standard form packet. The authors are kind of convinced that we don't need to continue this concept because it hasn't proven to be useful yet, but it appeared it was a concept our founders introduced into the original framework. So we're actually talking about going to the other end of the spectrum here, right, of making the biggest packets we can, and even when they're big, we want to make them bigger with measurement information. So maybe this is minimal standard form packet is a concept we get rid of. So after we've discussed these three things, and this is a fairly short draft to read, I would hope that folks would take a look at it, and especially if you're IPv6 interested or IPv6 fluent, we'd love to get your feedback. And once we've finished these, any new comments and these points, we would like to see a working group last call. So I'll open the floor for comments. I'll ask with great anticipation, how many folks have read the draft? Okay, one guy. Thank you, Jason. And Karidi volunteers to read it. and so so that's obviously that's what we need to happen, folks. We need more people to take a look at this. It's not that long, and if you're ever intending to use our metrics here with IPv6, it's very important to you. So that's my commercial. Anything else? Chairs?
Any questions? So we need people to read the draft and comment on the list. Yeah, I'm encouraging people to read it and make their comments.
Okay, good. Well, thanks for your time. I'm way ahead of schedule.
Yeah, woohoo. So one comment that Spencer had that he mentioned in the Meet Echo or Jabber, one of the above, is that the people who hummed against the IOAM data document, we'd love to hear your reasons and why you're opposed to it, and please express this on the list. We are running tight of time. And okay.
Thanks, everybody. But if you want to review this and you're willing to sign up, let us know. Give us some names of folks.
Yes, yes. So if anyone
we think they're going to be
read the
testing with
draft?
IPv6, besides Karidi.
Okay. So let's move on. Next, we will have a discussion regarding from Sudan. So, oh, okay. So we're going to discuss, yep. Okay, yep, we got some take notes, okay.
Hi, good morning. Sarah,
Um,
can we go to the next
We
slide?
didn't bring it up, no.
So the basic objective of this draft, I mean, this is we are proposing the model. Actually, we are not going for any protocol, but this is we are defining some performance measurement models, various performance measurement models for various services. So this defines various models which can be implemented. It is agnostic to any underlay technologies. So what is the motivation for doing this? Because now, I mean, network is going to a more and more granular level of monitoring it, and the customer requires a high amount of service uptime, and they want to know what is going in the network and analytics to be carried out, like big data and machine learning things are coming up. The providers are implementing it. So this the current scenario we don't know when it is up, when it is down. So what are the things which is going in the network for a particular service? We don't know. So that is one motivation, and the ITU is also working on a framework on network analytics, and the Institute OM is coming up, but it does not discuss much on the performance monitoring and what is happening with the customer services. So that's a motivation for writing this draft. Can we go to the next slide? So these are the status. The previous comments from Greg, like he was asking about the hardware limitations, then the glossary part and the format from Vinayak, and the format has taken care, and sections have added the SLA driven services, which Greg was mentioning about, that was incorporated. So next slide. Thank you. So this is a use case, a typical use case, this is on a point-to-point services where the customer requires, a particular voice service. They want a 40% of the bandwidth rate, or service say 30%, 20%, and 10%. So they define the service. That is the agreement between the end customer and the provider. So how do we define it? How do we measure it? So the current scenario, it is not in a position to do that. So here we are proposing the models for this kind of scenarios. It can be used for a point-to-point service, or point to multi-point, or multi-point to multi-point services. This can be used, and this model can be used for measuring the service based on the SLAs. And we are defining certain models to that. This is a typical use case for a point-to-point service. The end customer is subscribing and is sending different kinds of traffic, and he wants a different SLA, and he wants to monitor what is happening, and the provider wants to give him analytics on what is happening, and this is a performance monitoring data. This is a value addition service, and based on the data, whether he can go for upgrade or he can have a preferential billing, like that the providers can do. This will be giving more service to the end customer. Can we go to the next slide? Thank you. So this is a typical metering process. The data is retrieved from the routers and upload to the central system, and the timestamp is also captured. So with the help of the analytics is not the scope of this draft. The real analytics can be pulled out with any big data or machine learning. So this the metering from the metering process, the data can be retrieved to a central server where the analytics can be taken care. Can we go to the next slide? So these are the different models which we are proposing in this draft. One is a complete loss measurement in one direction, and color-based measurement, and cost-based data measurement, cost and color, and active passive measurements. So these are the 5 models which we are proposing. So we define the models. We are not, as I said earlier, we are not defining any protocol. These are the models which can be used to develop the performance monitoring to the end customer. So can we go to the next slide? So this is a complete measurement. It can be suitable for the backbone traffic. What is happening? It's the loss measurement in one direction. What is happening between the two endpoints? This is suitable for a backbone, so the provider can see how many packets which is going, and is any loss which is happening. So it is basically suitable for the backbone measurement. So the next slide, Sarah. Next. Yeah, sorry, back can we? Yeah. There's a color-based measurement. It is like we have defined, CIR and the committed information and exceeding information. So that data can be captured with this. So if the customer says, okay, this is my SLA, so are we sticking to that particular SLA? So we are having the color as well as, the color is, we are defining, okay, the customer is having this, the X is a CAR, and if it's exceeding, the provider can keep a tab on it if it's, he is sending the excess rate. So based on that, he can increase proactively tell the end customer to increase the bandwidth, or he can preferential billing during, peak hours or like that, he can do it. Next slide. And the cost and the cost-based measurement is like each customer, based on their services, the end customer services, the performance can be measured and it can be tabulated. So if the cost defines the SLA between the customer, what all services needs to be measured, that can be defined. And based on that particular each customer services, this the packets will be counted. Yeah, yes, Greg. Okay, so that is that's a cost-based measurement. So this is flexible based on the customer requirements. So can we go? Yeah, this is cost and color. This is which is the cost is defined by the customer SLAs, and the color which gives more granular, like if it is exceeding the exceeding that particular committed rate. So this can, for each particular services, this can be metered. So this model gives you granular level of measuring the committed that's a color, as well as for each level separately it can measure it. So the next, yeah, this is active, and that is like it's one example is an alternate marking draft, and this can be used like per flow basis. It can be marked and it can be metered. So this is active and passive measurement. So this is and the last one. So the next step, we have a room for development for the delay, and comments have anticipated, and it has to be reviewed.
Okay. Yeah. Greg Mirsky, ZT. If we can go a couple of slides back. So when I read this document and I look at different combinations of parameters that you combine to say, okay, now we're going to do measurement based on this criteria and this criteria. So there is another terminology to do this. So basically what you're defining what the qualified packet for your statistic is. So there are rules of qualifying the packet to be counted or measured. You just modify based on what you want to measure, but it's still a definition of qualified packet. I can point and reference you to another work that's being done at the Metra Ethernet Forum in work of IP service attributes definition. And there is a document now which documents UNI for subscriber services, IP subscriber services. And when I look at this document, I think that this document is very much implementation agreement for the UNI. So you have a UNI, you have certain SLA profile with a different committed rate, access rate, and everything. And that's basically defines your qualified measurements. So what you want to measure based on your SLA agreement between subscriber and operator. And one last comment, you noticed that I was nodding. I think that if you want to measure on real traffic, then I don't think that active OEM is applicable, because you effectively are doing it passive measurements. Whether you're using alternate marking as without impact on the processing of the packet, so basically their use of alternate marking is as passive as possible, that doesn't make it active OEM. Active OEM usually characterized as you inject special test packets to do performance measurement. So I understand your proposal is not about that.
No, it has, as I said, like it has active and passive. I was just, quoting one example of passive as alternate marking. Active, or it can use for active as well as the passive. That model defines that. So let me clarify that.
Yeah, for active, again, for active, you don't really need, because you create this packet in the way that you want to be, with all their markings and indications, and then you can collect it. So that's a thought, because to me, the reference to active OEM was a little bit strange in this context of this document.
Thank you.
Yeah, hi, Nalini Elkins. Yeah, Sudhina, I'm just wondering, in your model, are you giving any thought to a number of the hybrid things that are coming out?
And Nalini, I didn't follow you. I mean, what do you?
There's your model talks about active and passive.
No, we are defining the models. Like there are the different models. Like you have a cost base. Like each services, like the customer will have voice or data or different. Like you define the service, like service A, B, C. So that each service can individually measured and based on the committed information and exceeding. So that's one way of doing it. The color and cost. That is color. Color gives you the exceeding CIR and EAR, and the cost is just each services. It's measuring the packet. So it's metered and it is timestamped and it's metered and it will be uploaded to the server. And where that's, how the data are processed in the server, it's beyond the scope of this draft. It can be done with the analytics, real-time analytics, to a granular level to what is going in the network, and whether it will tell the provider to upgrade the bandwidth has to be upgraded, or it has to be preferential billing or some value-added service given to as a proactive measurement. So that will improve the customer satisfaction. So, yeah, thank you.
So how many have read this draft? So I'm seeing 4 people. I guess one thing that's been a concern for the chairs is that there hasn't been much activity on the list. I guess I'd like to see more discussion before we pursue adoption and hopefully get more people to read the document.
Yeah, thank you.
Thank you. Greg, yep, you're up. Greg Gumersky is up on TWAMP Light Yang.
Okay, so next, please. Okay, so the first and most important thing that we want to bring attention and stress is that according to RFC 4656 OWAMP and 5357 TWAMP, the use of the control protocol, OWAMP control and TWAMP control, is optional. So the purpose of this Yang model is to be able to instantiate their TWAMP test session in SDN environment without use of control protocol. I see that Alice disagree strongly.
I don't understand that sentence at all. It can't possibly be true, Greg. I don't know what you're referring to, where you think that the control client and the server communications and the protocol between them is optional.
In order to instantiate the T1 test session, I will go back to 5357, not now, but I will send the exact quote that I interpret this way. And then you can point...
Whatever you're interpreting, it can't be the interpretation that the rest of the world shares.
Okay, I disagree with that.
Yes, I know you do. But even TWAMP Lite, the picture that begins the TWAMP Lite informative appendix,
right,
includes control client functionality. Yes, it does.
Okay, the control, but not T1 control protocol. We're talking about...
But you're saying the control client is...
No, I'm talking about use of T1 control protocol is optional. That's what I'm saying.
It is not. It is not.
Okay. I'll go back to RFC and I'll send the quote. Okay, so in SDN environment, config client can talk directly to session sender and session reflector in order to instantiate T1 test session. Next slide, please. So based on this premise, based on this document that is to control T1 session. We had several versions of this document, so now we're at version 7, and the changes from Seoul to Chicago brought us to from 3 to 7. So the main changes are that to support authentication, we are using keychain model rather than replicating all the possible authentication in the model itself. Can we go next? So we define the interval as a microseconds, and we do have very good discussion on the list. And the question was, why the choice of microseconds and what the scenario could be. Open to discussion, but the case that we have in mind is that if somebody decides to use TWAMP for the synthetic loss measurement, which might be not the perfect choice, but still, I believe, valid application, then probably microseconds will come handy. Next slide. So the next steps, we do have comments that came after the cutoff date that some of them we agreed and will incorporate in the next version, but there are some questions that we want to discuss. One of them is a continuous mode. So the continuous mode understood as, well, there are differences in interpretation, what we and our colleagues see as a continuous mode for the T1 session. One of them is that it's a unbound test session where the measurements being taken at a certain point of time periodically. And another mode is more in line with will be coming from LMAP model, is that it's a sequence of T1 test sessions repeated periodically with or without interval. So that's something that we'll be discussing, and I appreciate anybody interested to join the discussion on the list. Then there are a couple other discussions related to session performance metrics expression, especially whether we have reflector stateful or stateless. As was pointed out, that it will help to the sender to know their mode of the reflector in order to generate metrics more efficiently, whether include one way or not include one way. DCP monitoring been addressed in RFC 7750, and there is some interest from mobile operators because cost marking caused a lot of problems if you have multi-service, like you have 2G, 3G, and the 4G in the same network. You mark them differently, and if there is some mistake in the marking, then you see packet drops in, for example, 3G, while 2G is riding happily. So DCP monitoring is intended to help to do the one-way cost monitoring, and it being welcome, so we probably adopt it. And of course, we always welcome comments, and we would like the working group to discuss how this document can proceed, because we do have adopted TWAMP model. So if there is any recommendation, suggestion, how we go with this document work will be good.
Okay, so Yakov's team mentioned on Meet Echo in support of Greg's statement, RFC 5357 says, quote, this example eliminates the need for the TWAMP control protocol and assumes that the session reflector is configured and communicates its configuration with the server through non-standard means, close quote.
That's in the TWAMP Lite appendix.
Okay.
And it also says in the body of the document that TWAMP Lite was established as a first step so that people could begin to embrace the TWAMP protocol by implementing TWAMP test first and then going on to do the full control. And that's what it says. And some people have been using TWAMP Lite for years and years and years, ignoring the sentence in the body of the document. So in the informative appendix, I'm not very excited about something being optional. That's distinguishedly different from the standards track protocol. That comes as a surprise to you, Greg? Come on. Let's
No.
waste our time with that.
No. Okay. Again, I want to point out that in SDN environment, we can absolutely control the test protocol without need to introduce control plane, which we view as an overhead.
Okay, so do we still need clarification?
All IETF protocols have to have security option. Security is mandatory to implement. It's not mandatory to use. Without the control protocol, you don't have the way to exchange keys.
Well, we have control, key chain. So are you saying that, for example, netconf is insecure transport? Or are you saying that using key chain, I cannot define authentication or security for the test?
I'm saying that the security considerations of TWAMP include what has been considered and standardized in the TWAMP spec, not some other cobbled together solution. And there is no standards track document that describes what you just, the process that you just gave.
Well, so you say that netconf is a not standard solution?
I did not say that.
Okay, so then where is the security concern of using netconf to instantiate the test session?
As far as I'm concerned, netconf isn't part of the discussion here. We're talking about TWAMP.
No, but we're talking about using netconf instead of TWAMP control to instantiate test session.
And so you need a document that says how to do that, that the security area can review.
So this document would be this document which explains the
This
using.
is a model. This is a model. It's not
No, this document, that's why I emphasized the first slide, which shows the picture that configuration used, communicated over netconf is used to config server and config test session. So that's exactly where it says. That's why I emphasize this slide, because this slide changes the paradigm.
But at the point where you made this statement, you said that TWAMP control was optional. And we have now concluded that because that statement appears in an informative appendix, it was incorrect.
Okay, again, I will go back to 5357 and I will look in the body of 5357 and 4656, which predates, and I will try to find the wording that support my point of view in the standard part of the text. But again, in regard to the security, that's the model that we are proposing. And I would like to have comments of where this model is insecure or not standard based.
So we need to move on. We've got 2 lightning talks. I won't get 10 for it. Now the broadband forum. Yep, you're up.
Yeah, just very, Dave Allen Erickson. Just very briefly, there is a liaison from the Broadband Forum with respect to TWAMP Lite, in that we are interested in adopting and referencing this work in a document we've got going forward, Working Text 390 on performance measurement from the IP edge to the residential gateway, which is effectively a single IP hop, is the particular application. But it's, again, to observe, we are interested in seeing this work progress, and our community is also, will be participating on the mailing list, of course, as individuals to help progress the work.
Great.
So,
Great. Thank you. So we need to move on. Next presentation by TEL, multiplex alternative marking. And you're up.
Thanks. My name is Tal Mizrahi, and this draft is based on a joint work with Giuseppe, Mac, Vero, and Greg. Next, please. We'll start with some background. So the purpose of alternate marking is to measure loss and delay in an accurate way between two measurement points, MP1 and MP2. One of the advantages of alternate marking is that MPs can be activated anywhere along the path without inducing further overhead. Next, please. So how does this work? Basically, traffic is split into blocks, consecutive blocks of data. Each block is assigned a different color. So we're typically going to have a color bit in the header of every data packet, which indicates which color it belongs to. And in each block, we also select one packet, which is used for timestamping. And this allows the two endpoints to timestamp that packet and to measure delay. So we're typically going to have two bits, color bit and a timestamp bit. Next, please. So in this draft, we define a multiplexed marking method, which means that if we don't have enough space in the packet header for 2 bits, we can actually use 1 bit, which is the result of the exclusive OR between the C bit and the T bit. And it turns out that using just 1 bit, we can measure very accurately, and we can use the alternate marking method with just 1 bit. Next, please. So what have we done in the current version of the draft? The major change we've done is we talked about 1 bit in the previous slide. So rather than having just 1 bit in the header, we added an option to have a field which is longer than 1 bit, but can have 2 possible values, which indicates the 2 values we talked about earlier. And it turns out that even if you have 2 separate values in a larger field than 1 bit, you can use the same multiplexed marking method. It works the same way. So one example for where this will be used is MPLS. So actually, Giuseppe mentioned this earlier today. There's a draft in the MPLS working group which discusses how alternate marking can be used using MPLS synonymous flow labels. So this is one of the first use cases for this, and this can be used in other transport types as well. Next, please. Okay, so this draft was first submitted in October 2016. It was presented in IETF 97 in the IPPM working group. There was also some discussion about this in the MPLS working group in IETF 97. In March 2017, we submitted draft 01. There was also a demo at the OCP Summit. Marvell, the company I work for, has demoed alternate marking using the multiplexed marking method. So it's not theoretic. It's something that actually works on real devices. As the next steps, we would like more feedback from the working group, and down the road, we'd like the working group to adopt this. Any comments would be welcome.
Any questions? Okay, thank you.
Thanks.
Okay, and the last speaker.
Okay, hello, my name is Klaus Nieminen, and I'm talking about the intergraph, talking about the net neutrality measurements. Next slides, please. Well, basically, this draft is talking about the regulatory use cases and the problem statement. We are not defining, or I'm not defining any metrics there, but its purpose is to give the adequate information for the whole community so that we can actually get people developing measurement metrics, what the, for example, the European regulators can use. So this is really about the sharing the information and hoping to get some community feedback and proposals, and hopefully also new standardized metrics, so we can actually get these, I would say, best practices to be spread a bit wider. Well, we are targeting to measure the Internet access service quality. I would say that this is better understood, and we have some measurement metrics already there. We are trying to identify the traffic management practices that may impact certain applications. So, for example, if an ISP is throttling or prioritizing the traffic, we want to detect that. And that's a bit more challenging area. And well, as I mentioned, we are trying to measure the Internet access service quality that excludes the end user environment. And also, then we are trying to measure the ISP traffic management practices that also excludes the end user environment. So we are trying to get the information regarding the measurement setup, measurement conditions, the calibration, as Al mentioned in the early morning. And well, next slide, please. I think one of the main problems is also that, well, if I could install a hardware probe, that would make the measurements much easier. If I could install the measurement client to the modem or router, that would make also the measurements much easier. However, well, basically they are trying to get a tool that can be distributed to anybody, basically to the all end users. You're trying to get a tool that can be run basically in any environment. That means this kind of the crowdsourcing tools based on the web browsers, mobile apps, and that also limits the capabilities on what kind of the measurements we can make. So that's I think one of the additional challenges that, well, we have received actually quite plenty of the comments, not in the list, but I got personally really nice proposals, and thank you for that. But I think one of the key issues is that how we can get really this kind of the measurements that can be well spread with the crowdsourcing tools to a large audience, and they should be rather easy to use. Because let's say that my mom is running the measurement. Well, we can't really require much information from her. And well, as I mentioned, we managed to get the Intergraph online. And basically my question to the group and the chairs is that what I should do next. I mean, we are already achieved at least partly our goal to get some attention, get people thinking about this. Thanks.
Okay, great, thank you. Yeah, I think we want to have some more discussion on the list and then go through. Cool, thank you. Nalini?
Yeah, I'll keep it quick. I know everybody wants to go. I think this is very, very important, and especially in the light of potential changes in the United States regarding net neutrality. And I've already put to the list a proposal to have PDM, which has information embedded in the packet and is very simple to use. Anybody can use it. You don't need to do anything. It's embedded. And of course, one of the problems is that people haven't gotten into their OS yet. But I've gotten 3 different communications from people who are, before the draft is completed, they say it's in ISD last call. People are starting to implement PDM in Linux already, and I have 2 other proposals. One of the things that I'll do for next time is post how PDM does what you want, and also if people can have heart attacks later, but PDM for IPv4.
So one other question from the Jabber room. The speaker talked about measurements. Can RIPE Atlas be used in these measurements once the framework is decided? And there's another comment that RIPE Atlas does have some limitations.
Well, I think we are now in the phase of trying to identify really the best practices and the best possible tools. So I think, well, there are plenty of options what can be used there. However, I'm emphasizing that are, for example, trying to get, well, the really large audience, I mean, a lot of users for these clients. That is especially related to the quality of service measurements. So I think the RIPE Atlas or that kind of the measurements are probably a bit limited as we actually need to distribute probes.
Okay, so we're out of time. If anyone hasn't signed the blue sheets, please sign them. Thank you for coming, and we'll see you on the list. Thank you.